Hello, welcome to Progressive Farming Company's how-to series on managed grazing systems. I'm Emily, I'm the sales manager here at Progressive Farming, and I'm joined by James, who's the director.
Hi Emily, thanks for inviting me.
You're welcome. So in this series today, we are going to cover everything you need to know about designing your own grazing system. So who is Progressive Farming? Progressive Farming, we are a UK business, an online UK business, supplying electric fencing equipment, mobile watering equipment for livestock, plus energizers and tools. We are the UK stockist for Kiwi Tech. We also stock Hayes, Pell and Speedrite. You can find everything we stock and do on our website, www.progressivefarming.co.uk. There we list the whole range, including helpful how-to videos, all of our pricing, and you can buy direct on the website through our online shop. So I'm going to hand over to James now, who's going to talk through what we cover in this grazing series.
Yeah, thanks Emily. So this series is a 5-part series, and we're going to cover everything you need to know about how to design your own managed grazing system. That's going to include the benefits of managed grazing, design of the system, electric fencing, energizers and earthing, and water systems. So we look forward to sharing our knowledge with you, and we really hope you can join us and you'll also enjoy working your way through this 5-part series.
Hey, and welcome to the Progressive Farming Company How-To series. This is part 4, Energizers and Earthing. So if you've not checked out the other videos in the series, then please do so. The first one covered the benefits of managed grazing. The second covered grazing system design. The third, electric fencing, including posts and wire. This fourth part covers energizers and earthing, and there's a fifth part to check out, which looks at water systems.
This part has quite a lot of content to cover, so if you're short on time, looking for something particular, or jumping back in, here's a short table of contents with the key topics and the times at which they start in this video.
So, electric fencing, as we know, is low cost and quick to erect. It's an essential tool for grazing management and grazing management systems. However, there's some important differences between electric fencing and conventional stock fencing. With conventional stock fencing, what's really important is the strength of the materials, whereas with electric fencing, the important parts are the recognition that it's a psychological barrier rather than a physical one. For it to be an effective psychological barrier, the fence needs to have the correct and consistent wire height and must be powered with sufficient voltage, or the wire must carry a sufficient voltage for the animal to, when they do touch it, to get a suitable shock so that that reinforces the psychological barrier and they don't touch it again. So conventional fencing is very much a physical barrier, electric fencing is a psychological barrier, made tougher by the consistency of the wire height and having a suitable voltage. And so this part 4 is going to talk about how do we ensure we have a suitable voltage in our fence. For more information about number of wires, wire height and post spacings, please check out part 3. So let's have a look at energizers and what they do and what options there are. So the energizer is the component which is going to power your fence. It's the piece that generates the electrical charge that it sends out as a pulse through the wire, and that pulse is a pulse of current which has an applied voltage. It's the voltage the animal feels when they touch the fence, and it's what delivers the shock to the animal to make sure they don't touch it again. There are a number of options. There are more than a number. There are many options within energizers, but we can group them together in terms of how or where they take their power from. So some are powered by mains electric, some are powered by batteries, and some are powered by solar, and the Unigizer range from Speedrite can be actually powered by all three. So before we decide how we're going to power our Energizer, or what's the most suitable source of power for your system, you need to understand, or need to be able to work out how much power you need, i.e. what size Energizer do you need for your system or for your fence. So when it comes to Energizer size, they're normally sized by their power rating. So an Energizer output is rated both in stored joules and output joules, and those are standardized units of measure, a bit like miles per gallon. With stored joules, it relates to the energy or power stored inside the Energizer. Due to some internal resistance, the Energizer will always output less joules than it can store. So it's therefore that it's the output joules that you should be looking at and comparing when you're looking at different Energizers or across different makes of Energizer. The output joules relates to how much energy or power is actually available from your Energizer to go into your fence or fencing system. Very simply, the more output joules you have, the more likely you have enough voltage through your fence or on your fence, even if there's vegetation or faults on the fence. So the more powerful the Energizer, the longer fence it can power, or the more voltage it can put in the fence when there's vegetation touching. All of the Energizers, regardless of type, will supply the same amount of voltage. It's how well they can deal with distance and how they can deal with resistance that differs. So the more powerful Energizer won't supply the fence with any more volts, but it'll be able to maintain those volts under higher loading, such as resistance or longer fences. So when it comes to selecting the Energizer and answering the question, what size do I need? It's worth planning your system and calculating the length of fencing that you have, then multiplying it by the factors below. So the reason we're going through this process is because most Energizers will tell you on the box that 1 joule is sufficient or suitable for powering 10 kilometers or 10,000 meters of fencing. That might be true in theory, but it's never true in practice. So what we're going to talk you through here is a little process to help you work out the actual power requirement you will need for your system to deal with things like vegetation and also to deal with things like using polywire. Polywire, because the metal filaments within the wire are much, much thinner, it has much higher resistance, and therefore the Energizer won't power such a large distance of it. So let's have a look at this little process. So planning the system, so that's really important. Think about what fields are you going to fence, how many fences are you going to have, and then within that system you should split those materials into 2 types. One will be your permanent fencing or any fencing using high tensile steel wire. High tensile steel wire is the lowest resistance. Still, it has some applied resistance, and there's always resistance around things like switches and underground cable and so on. So for the high tensile steel wire, if it's in contact with no vegetation, you multiply the distance by 2. If however, there's going to be vegetation, so maybe the fence is going to run in front of a hedge, and it's likely there'll be leaves and weeds and things touching it, you'll multiply that distance by 3. If you can use some temporary fencing, maybe to subdivide fields, then any distance of temporary fencing or polywire is going to be multiplied by 10. That indicates the much higher resistance or poorer conductance that polywire has compared to high tensile steel wire. So from that you can calculate the total distance and then divide by 10 kilometers to find the required Energizer output. So we'll go through a worked example just so you can see what this looks like. When multiplying or calculating your length, you only need to worry about the distance of fence on the ground and not the number of wires. With a 3-wire fence, the current is able to flow through 3 of the wires rather than 1. So per meter, the resistance, per meter, a 3-wire fence should have a lower resistance than a 1-wire fence. However, more often than not, something like a 3-wire fence will have a lot more vegetation contact. The lower wire or the bottom wire is closer to the ground, much more likely to have grass and other stuff and other things in contact with it. So again, as a rule of thumb, we'd normally just simply work on total distance of fence rather than total distance of wire or number of wires. The advantage gained from additional wires is normally lost at some part of the season due to more contact with vegetation. So the method we use keeps it a little bit simpler. So let's start with this example. We're going to erect a single 3-wire electric fence that's 400 meters in length. So applying the theory discussed on the previous page, 400 meters divided by 1,000 meters is 0.4 kilometers. we apply our multiplication factor of 10 because it's a temporary fence, it's using a polywire. So 0.4 kilometers times 10 is 4 kilometers. We then divide by 10 kilometers to find the required output in joules. So 4 kilometers divided by 10 kilometers is, of course, 0.4 joules. So that's 0.4 joules of output power that would be required. If we look through the catalogue, we would see that the recommended energizer, if we wish to use a solar energizer, would be the SpeedRite Solar S500 with 0.5 joules of output. In this example, we have 8 kilometers of permanent electric fencing with hedges behind. So because of the hedges and the potential high vegetation loading, we'll multiply the 8 kilometers by 3 to get 24. And there's temporary fencing totaling 3,000 meters, so total distance on the ground. 3,000 meters divided by 10,000 meters gives us 3 kilometers. 3 kilometers times our temporary fencing factor of 10 gives us 30 kilometers. So if we add the two together, we get 24 kilometers plus 30 kilometers, a total of 54 kilometers. Dividing 54 by 10 gives us the required output joules, which equals 5.4 joules of output power. So therefore the recommended energizer should have at least 5.4 joules of output power, which is likely to go slightly higher. So hopefully those two examples give you a good idea of how to work out suitable energizer size. And when thinking about how much fencing you have, think about what you have now and what you may have in the future. There's never the price difference to go up a size in energizers, never as large as to have to buy a new energizer in a couple of years' time. So it's always worth over-speccing in most cases. So if that's covered how to select the power output or choose an appropriate power output, let's have a look through some of the Energizer options. And let's start with mains energizers. So mains energizers are the largest energizers that you can purchase. So therefore they'll supply the most output power, they'll power the longest or largest distance of fencing. And again, you see here in the sort of advert piece for these energizers made by SpeedRite, it says the 64,000W powers up to 150 kilometers of fencing. It's 46 joules maximum output energy. So it's got 46 joules of output energy, and you can work through your examples to find out how much that will power in reality. So these larger energizers are really useful units. They've got a number of features to provide sort of a large amount of reliable power. Again, they won't supply any more voltage necessarily than a solar energizer or a battery energizer, but what it means is that the power output, they can cope with a lot more resistance. So the 64,000W Energizer would be suitable for very large farms, so possibly up towards 800 acres in size, depending on things like vegetation loading and Energizer location. That Energizer is Bluetooth and Wi-Fi enabled, so you can download the free Datamod's Livestock app and be able to view the Energizer voltage from anywhere in the world, as well as turn on or off the Energizer via the app. That's true when the Energizer has a Wi-Fi connection. If it doesn't have Wi-Fi connection, you can use the remote control, which we'll talk about later. And it's the same with the A15XI. That one's got 15 joules of output energy. And again, that one's remote controlled compatible. So the remote control means you can turn both Energizers on or off from wherever you are on the farm. And that's very, very useful for fixing faults in the field. Both these Energizers, as with all SpeedRite products at the moment, come with a 5-year warranty, which is nice to have. So you can see there some of the more features. These are large Energizers for professional users. They've got big terminals. They're designed to take a really good size underground cable when you're making your connections between the Energizer and the earth. The interference is very low, so you do get a huge amount of power from the Energizer. Nice simple light bar display showing you the voltage that's in the fence, and say controllable via the app or with 4600, or both controllable via remote control. So other mains battery and solar energizers, what SpeedRite have is a range of models which it calls their Unigizers, I guess uni being multi. So these Energizers can be powered from the mains via battery or via a solar panel setup, which we'll talk about in a bit. So main products in that range are the 1500i, which is 15 joules of output energy, output power, the 3000i, 3000, which has 3 joules, and the 6000 and 6000i. Now, the I means it's compatible, remote control compatible. So the 15,000 with 15 joules and the 6000i with 6 joules, they can both be used with a remote control. Again, so a feature worth having in mind. It does save a lot of time out in the field, and that means less need for things like cut-off switches, because you can turn the power off with the remote. The 3000 and 6000 are not remote control compatible, and they're just simple, solid mains, battery or solar units that will power a decent area. And again, you can go through your calculations to work out what size Energizer you truly need with those models. The 15,000i in particular is probably particularly good value for money for a 15 joule mains power Energizer. Because these are also work with batteries and solar, they contain a number of operating modes which are maybe slightly different to the mains Energizers. So these Energizers have a daytime and nighttime mode. For different stock classes, for instance, if you're running these with deer, you may well operate them so they pulse quicker at night and slower during the day when the animals are more or less active, and vice versa. They also have half power model modes for battery saving or for lighter or shyer stock classes. And they have a battery monitoring mode. When running that mode, the Energizer will adjust its pulses to try and maximize battery power, particularly when the battery gets low. So they'll work with you to try and make sure there's always a pulse in the fence, even if it's not as regular as it would be with a full battery. So, as we said, they can be installed and used with the solar panel, or any one of 3 combinations. And this infographic shows those 3 setups. So, bottom left, we've got a solar panel setup. You can see the solar panel indicated there. That's connected to the battery, and then the Energizer takes its power from the battery and sends it to the fence. Now, that setup's not available off the shelf, certainly not in this market, but it is relatively easy to set up. If you were to get in touch with ourselves at Progressive Farming Company, we can talk you through the specification you may need for the battery and for the solar panel. When set up correctly, it's quite easy to power the 6 joule or even the 15 joule Energizer completely remotely with this type of setup, and for it to last 12 months of the year. The other setup options are again with mains power, so it comes with a 3-pin plug. Simply plug it into your mains power supply. The Energizers can be situated outside. They're completely weatherproof. The Unigizer range, it's completely weatherproof. Obviously, if you're using it with mains power, you need to make sure the plug is in an outdoor socket, suitably located and installed by a suitably qualified person. The same Energizer also comes with a set of crocodile clips, so a set of leads that will attach directly to the battery, and you can use it straight from there. So, sort of last maybe option is the solar Energizers, and these are, as they sound, powered with solar, so they contain a built-in solar panel and a battery. Really helpful and really useful for moving around because it's a self-contained unit. It's got a set of leads that clip on the back. It's got an on-off switch with a light to indicate when it's on, so the light pulses with every pulse. And they're well spec'd, so certainly in England and Wales, they'll generally run for 11 or 12 months of the year, again, as long as they're suitably sized for the fence they're powering. In Scotland, they may need a bit of recharging through the depths of winter, again, depending on the size of the Energizer and the length of fence it's being asked to power and the resistance. But the model ranges here go from an output of 1 joule down to 0.08, with a couple of models in the middle. And on the whole, they're fairly idiot-proof, I think would be the expression. More expensive than it would be perhaps to buy a battery and a small, a battery Energizer. The issue with that setup always is you don't just need 1 battery, you need 2 batteries because you always go 1 on charge to replace. And half the time when animals escape, it's because the battery's gone low or the battery's gone flat and there's been no pulse in the fence. So solar Energizers have certainly solved the probably main reason for animals escaping through electric fences, and that is no voltage or no pulse in the fence. So worth considering, especially for temporary fencing setups, although the one dual unit would be capable of powering some of the larger, sort of more semi-permanent setups as well. We said number of features, 5-year warranty on these as well, which for something that gets moved around quite a bit is really, really good. They can be mounted and hung on a wooden post or on a steel post. Again, slightly intelligent in the fact that if the sunlight's low, they'll reduce the pulse frequency. So they'll always keep a pulse on the fence, just not always as often as when it's bright sunshine. And the batteries will go a reasonable time without direct sunlight as well. So they are quite flexible units as long as they're suited to the fence they're powering. The common mistake would be to try and use a small solar unit to power a long fence, and for the solar panel just not be able to keep up with the demand of the resistance in that fence line. So spec appropriately and try and do calculations to work out what size you need for the fence you're trying to power. So I'm going to look at sort of management tools, and you see that it mentions a couple of options. So remote with fault finder. So that's for the two larger mains Energizers, the 46000 and the AX15i, as well as the Unigizers with the I designation, so the 15000i and the 6000i. They have the remote control feature, so it is and looks like a remote control. To operate it, you touch it, hold it onto the fence, press the off button, it sends a signal through the wire which turns the Energizer off. You can then make a repair, open a gate, whatever you need to do, hold the Energizer on or hold the remote on the fence again, press the on button, and it turns the Energizer on. Within that device, similar to the fault finder beside it, you've also got fault finding and volt metering, volt measurement capabilities. So when you hold it on the fence, it beeps every time there's a pulse, and with that pulse, it will show you the voltage, and it will also show if there's any faults in the fence line. And the fault finding is really, really useful, especially for larger systems where people might be doing things like leaving gates open on the floor. There might be polywire on the floor. There might be a branch or a tree on the fence. So if you start to power more of the farm, a fault finder saves you a lot of time. Again, hold it on the fence. If there is any faults, it displays it with an ampage, and then you sort of walk along the fault or walk along the fence. And every time you come to a connection, hold the device on both sides of the connection, and you follow the highest ampage to find where the fault is. And they do work really well. Below that, there's a couple other options which are more economical, and they simply do voltage. And it's really worth checking the voltage every day. If the voltage is good, there shouldn't be any problems with the fence. The animals should all stay in. Again, most common reason for animals escaping is a flat or low battery, or basically the voltage not being high enough. So digital voltmeters or even light testers are really good devices for keeping an eye on the fence. Speedrite even do a fence alert, which you clip on the fence and it flashes a light every time the fence pulses. If you've got a fence which is in view of the house, that's a nice handy feature to put on it, just to give you a visual reference that the system's still working appropriately. Worth just commenting briefly on fencing design. When you're designing a fence, the Energizer will go wherever the power source is. If you have a choice, the Energizer would go in the middle, but that's not always the case in terms of design and farm location. Wherever the Energizer goes, for power to be taken around the system, it's worth planning that on a piece of paper so you can erect it and make your connections in a logical fashion. When power flows into a field, it should flow around the outside and then should terminate before it reaches the end. So with electric fencing, we're not aiming to create any loops. And unlike water systems where joining up pipes would be a good idea, with electric fencing, to aid our fault finding, we will go around a field and then terminate. We won't go around a field and then join back into the fence again to make a complete enclosed loop. So it's just worth thinking about how you lay your system so that the faults can be detected quickly and easily, and so that certain fences can be isolated or turned off if a fault does develop. So it's worth putting a bit of thought into how you're going to do your connections. So as well as the Energizer power, Energizer output power being appropriate. So that's really key, having an appropriate size energizer for the fence you want to power, or the system you want to power. The energizer is nothing without the earth. And so we talk about earthing, or talking about earthing system. An earthing system consists of one or more earth rods. So an earth rod is a steel rod that goes into the ground. And the purpose of that rod is to provide an effective path for the electric current to return to the energizer's earth terminal when the animal touches the fence. Now, earthing is a particular challenge in dry conditions, and a much bigger challenge in sort of sandy or thin or dry soils, or non-conductive soils, of which we don't have so much in this country. So if we do have poor soils or dry conditions, there's a number of options we can look at, and we'll look at those in the next few slides. Beyond that, as a simple rule of thumb to think about, for a rule of thumb or suggestion is that you should have 0.5 meters or half a meter of conductive steel in damp soil per 1 joule of stored Energizer output. So if the top foot of the soil, the top 30 centimeters of the soil is dry, that means you need an earth rod, probably 1.5 or 1 meter in length, to be able to drive it in sufficient depth to go through that damp region, through that dry region to the damp soil below. So Speedwriter put together some tips on earthing and earthing systems. We'll look at the options here sort of separately with slightly larger diagrams to explain them, but there's a way of connecting the wires on the fence to help aid the earth, particularly on dry soils. We think about an earthing site. So let's say we're using a 6-joule energizer. We apply a rule of thumb, which is half a meter in damp soil for every joule of output. So 6 joules times 0.5 is 3 meters. We need 3 meters in the ground, assuming that the soil is always going to be damp all the time. So let's say 4 meters to be on the safe side. So that may mean that we have 2 2-meter long earth rods, or maybe even 3 2-meter long earth rods if maybe our soil isn't so damp. Now, those 2 or 3 earth rods can be located really within a 400-meter range or radius of where the energizers can be sited. Of course, the closer the better, but that 400 meters is to give you some scope, because it may be possible to find a damper area, maybe a ditch, maybe a pond, maybe some heavier soil and an area that lies wet within that radius. So you're normally better going 100 meters further to find a damp spot than staying close to buildings and having an ineffective earth, or an earth you need to water all the time for it to be effective. So every situation is different. Again, you will speak to Progressive Farming Company if you're unsure of where to site your earthing system. What is key, however, it needs to be at least 10 meters away from other earth systems. It shouldn't be in line or underneath any electric power lines or phone lines. And of course, check with relevant suppliers before driving these 2-meter long earth posts into the ground, because 2 meters is a long way, and you can easily contact electric wires and other lines you don't want to. Keep the earthing system away from stock and traffic, because they might chew or interfere with installation. Make sure it's easy to get to maintain it. Doesn't need a lot of maintenance, but it's useful to check the connections every now and again. And always aim for where there's damp soil all year round. And that should be within 400 meters of the Energizer itself. When you're driving in the earth rods, we can probably have a look here. So here's some examples from earthing systems. The top left was for a 36-joule Energizer, and that's using 9 earth posts or earth spikes. And you see what we're using in these images is actually some metal wide profile posts. They're galvanized steel, and they work quite well, especially in sort of shillet or shale ground conditions where driving a narrower diameter post might be quite hard. Scaffold tubing also can work really well. Just needs to have high level galvanized on it and be strong enough to be able to drive it into depth. So the Clipex, or the wide profile posts in these pictures, have been driven into a depth of 1.5 to 1.8 meters, being 2 meters long themselves, and they've been driven in so they are 3 meters apart. And that's really a key part of an effective earthing system. The posts themselves are 3 meters apart, and then they're connected in series by 2.5 millimeter underground cable. And you can see in a couple of the options that cable has been run on the surface and sheathed in water pipe to protect it from from animals, from livestock, and from traffic. And then one example there is actually been buried under the ground. You're probably just using a spade to dig a shallow trench and bury it 6 inches underground, again to keep it safe. So all those posts are linked up, and that's the key component of this effective earthing system. So most energizers we set up like you see in this diagram. You have the energizer, whatever it is. The earth terminal will be connected to the earthing system. So there's the earthing system with a number of rods 3 meters apart and sufficient distance into damp ground. The live terminal of the Energizer will then be connected directly to the fence, and all of the wires will be live. This system then normally works when an animal contacts the fence. The current passes through the animal into the earth and back through to the earth rods or earth system and to the earth terminal of the Energizer. The animal therefore connects or closes the circuit and therefore experiences the shock of the current passing through them as it returns to the negative side of the terminal in the Energizer. So you can imagine that if the earth is needed to complete that circuit in dry conditions, that becomes a challenge because there's really not water is a good conductor. In dry ground, there's not enough moisture for the earth return or for the earthing system to work. So an alternative option, and one that's really effective, particularly when it comes to training animals or naive animals with the fence, is to set up an earth wire return system. So what this means is that there's live wires on the fence connected to the Energizer, but there's also normally at least one earth wire on the fence. And that earth wire on the fence is also connected to the earth or negative terminal on the Energizer. What this means is that an animal trying to push through the fence comes into contact with both the live wire and the earth wire, and therefore is effectively earthed through the fence itself rather than relying on the ground to earth the animal and to complete the circuit. So that is an extremely effective system, so especially when ground conditions are dry or earthing options are poor or limited. And it's relatively easy to set up, particularly if you're planning on running multiple wires on the fence anyway. So again, we can discuss this in more detail, but it's a setup that's really worthwhile considering, especially in multi-wire fences. Moving a bit further along the system, if it is a system you're installing, inevitably at some point you'll come to a gate. It's just important to note that if you're putting this effort into the earthing system and the speccing the right size of Energizer, it would be pretty pointless to kind of lose those benefits or lose that advantage when it comes to things like gateways by not following the correct technique. So to cross a gateway, the power should be taken in underground cable of a suitable size. Main size really being used is 2.5 mil, although 1.6 mil is an option. 2.5 mil normally matches the size of the high tensile wire that may be on the fence either side of the gate. So using 2.5 mil 2.5 mil underground cable should mean that there's no discerning drop in voltage as the diameter is the same. And with resistance or conductivity, wire diameter is really key. The larger the diameter, the less the resistance, the better the current, better the voltage. So when it comes to the gateway, underground cable, normally sheathed in water pipe, run from one side of the fence across to the other and attached to the fence, normally with crimps or sometimes with joint clamps, but crimps tend to be quicker to use. And again, any more advice on that, then welcome to get in touch. You see some other components there, so you may be using a cutout switch to isolate that side of the fence and insulators. So the sort of more complete fencing setup, then go back and have a look at part 3, and that'll talk you through sort of the fence erection piece. So some of the sort of accessories that we've spoken about, there's your underground cable. Again, these are all Speedrite products. So underground cable is high quality. It's a mild steel, galvanized wire, sheathed in 2 layers of plastic. Reasonably tough, but can still be scored and marked by stones. So if lying on the surface or buried underground, always recommend it's put in 20 or 25 mil, standard blue water pipe, just for extra protection. And it makes backfilling the trench you're digging a lot quicker then. So that's low resistance and highly conductive, and probably the material of choice for connecting the Energizer to the fence and for making these underground connections far more effective than using something like a bungee to try and take the power across a gateway or across the track. The heavy-duty cutout switches, so they're high spec and they'll cope with a lot of current flowing through them if needed. They're highly visible, both by the colour and by the design. You can tell when that's open, and it's open, it's off. You can tell what position that's in from quite a distance. You then got the earthing kits, so they are 2 metre long, 10 to 12 mil diameter galvanised steel rods, hardened. So they're relatively easy to drive in. The narrow profile sometimes makes them easier to drive in, as long as you've got the right tool to hit them with. So depending on your ground type, you might favour those, or you may favour sort of a wide profile steel post or some scaffolding tube. Whatever it is, having enough of it in the ground and making sure your connection to those earth rods are sufficient is really important. And then the last piece is the warning sign. Again, warning signs simply may be required by law, and they're certainly required by law alongside any public rights of way. Again, you can probably consult your local authority for more advice on that. Really useful safety feature as well, so one to bear in mind. And then, of course, it's the wire itself. And again, fencing and wire is probably covered in more depth in section 3, but it's worth touching on here. All wire is not equal. And so when it comes to things like high tensile wire, the larger the diameter, the lower the resistance. The slight exception to that is for something like cyclone wire, which is a really nice high spec fencing wire. It is high tensile. It's also aluminium coated. What it does, it means it gives the 2 mil version, which Progressive Farming Company predominantly stock and sell. It means the 2 mil version has the same resistance as a standard 2.5 mil high tensile wire that you would buy off the shelf. The advantage that gives you is that 2 mil wire is lighter, so therefore you can put your intermediate posts further apart. So 2 mil wire really is the weapon of choice when it comes to internal subdivision for reducing the cost per metre, and that slightly higher spec wire allows you to do so without compromising on voltage or conductivity. So it's a really good product, the 2 mil cyclone wire. On the left-hand side, you see some poly wires of various specifications. It's probably just a note to say that your standard poly wire is fine. It's got 6 filaments. If you look there, it's 6.4 ohms per meter is the resistance. If you come down and start to spec up things like the extreme poly wire or the premium poly wire, well, they've got larger diameter filaments. Some of them using copper, and they have a massive impact on resistance per meter. You can see that for the poly wire compared to the extreme, the resistance goes from 6.4 to 0.12. So it's a tremendous difference. That's a much lower resistance, and the breaking strain goes up as well. So depending on the situation, if you're moving the fence all the time, standard poly wire is fine as long as the Energizer is large enough. If you're leaving poly wire in situ for a longer period of time, maybe on some renter ground, it's worth considering how might you use something like the extreme poly wire product to balance with some more temporary or more short-term poly wire, like the standard product. The poly wire might cost more, but it's going to save you on Energizer power and capacity. So there's a bit of a trade-off there to play, and we'd always recommend going for a higher spec poly wire where fences can be left in situ for a while, because it's going to deliver a much higher voltage to the end of the wire with less resistance. So I hope you find it useful. That was part 4 in the how-to series from Progressive Farming Company. Contact details are on the slide, so with any further questions, please get in touch. And I hope you can join us in part 5, where we're discussing water systems. If you haven't already, go back and check out parts 1, 2, or 3. We hope this guide has been helpful, and look forward to dealing with you soon.